Okay, so this is example number 1 on, let's see, it's a little hard to do here. Let me, our 5-4 guided notes. So this is my example. I'm going to do this one, but you don't need to write it down. Just watch this one. And then what we'll do afterwards is I'll do student example number 1, and you guys can write that down. So what we're doing here is we're solving a radical equation. And the way we do this is we need to isolate the radical itself. So you'll see right here that both sides, that the left side has a 2 coefficient. So I'm going to get rid of that first to start to get x alone. So I'm going to divide both sides by 2, and I'm left with radical x plus 1 equals 4 divided by 2, which is 2. And now what I'm going to do is I want to get rid of this radical. So the way we undo a radical is by squaring it, because this radical is a square root. So I'm going to square this side, and if I square the left side, I must also square the right side. So when I do this, I'm left with this radical and this square, they cancel each other out. So I'm left with x plus 1 equals 2 squared, which is 4. And then I can subtract 1 from both sides, and I'm left with x is 3. I can check that pretty easily by rewriting the equation. And substituting in a 3 for x. And when I follow the order of operations to simplify this, I get 3 plus 1, which is 4. Radical 4 is 2. And 2 times 2 is 4. So I get a true statement when I check. The one underneath here is very similar, except that here I have a cubed root function. And then I have this minus 1 over here. So I don't want to cube this side until the root is the only thing left. So I'm going to start by adding 1 to both sides. So now I have the cubed root of 2x minus 9 equals 3. Now that my cubed root is alone on that side of the equation, I can undo it or get rid of it by cubing it. Okay, so the opposite of a cubed root is a cube. And if I cube this side, I must cube this side. So the cubed root and the cube undo each other, and I'm left with 2x minus 9 equals 3 cubed, which is 27. Again, I want to get the x alone here, so I'm going to add 9 to both sides, and I'm left with 2x equals 27 plus 9 is 36. I'm going to divide both sides by 2, and x equals 18. And again, that's pretty easy to check. And I'm not going to do a formal check for this one. I'm just going to kind of talk you through it. If I plug in an 18 for x, 2 times 18 is 36. 36 minus 9 is 27. The cubed root of 27 is 3. And 3 minus 1 is 2. So I can see visually that it checks. So this is the student example number 1. In order to solve this equation, just like mine, we were going to divide both sides by 2. Okay, to start to get that radical alone. So we have radical x plus 2 equals 8 divided by 2, which is 4. Now that my radical is alone, I can undo it or get rid of it by doing its inverse operation, which is squaring. So the opposite of a square root is a square. And if I square the left side, I must square the right side. So in essence, these two cancel each other out, and I have x plus 2 is 16. Subtract 2 from both sides, and I'm left with x is 14. And I can check that just by plugging it back into the original equation. In this case, we have 2 times radical 16 is 8. Radical 16 is 4, and 8 equals 8, so that checks out for us. The one down here is very similar. In this case, however, I don't have a coefficient, but I have a number being subtracted from this, this root. In this case, we have a cubed root. So I'm going to undo that minus 2 by adding 2 to both sides. So on this side, I'm left with the cubed root of 2x minus 5 equals 5. Now to undo a cubed root, I have to cube the expression. So raise this to the 3rd power. So these will cancel each other out. but anything I do to one side, I must do to the other. And 5 cubed is 125. And if you don't know that, you can use a calculator or you can look at your table of powers. Okay. From here, I'm going to add 5 to both sides to start to get my x alone. So I have 2x is 130. And if I divide both sides by 2, I'm left with x is, let's see, what is that? 65. Okay. And I can check that by plugging it back into the original. Okay. So if I want to check that, my original equation is, let's see. Sorry, I had to peek at that. Okay. So it's the cubed root of 2x minus 5, minus 2 is 3. So that's the cubed root of 65 times 2 is 130, minus 5, minus 2 is 3. A little tight on space. This is the cubed root of 125, minus 2 is 3. The cubed root of 125 is 5. 5 minus 2 is 3, and that is a true statement, so that's a good check. Okay, so this is example number 2. It says, in a hurricane, the mean, and in this case the mean is the average sustained wind velocity, which is measured in meters per second, can be modeled by this equation, 6.3 times the square root of 1013 minus p, where p is the air pressure, measured in millibars, so that's just a unit we measure air pressure with, at the center of the hurricane. It says, estimate the air pressure at the center when the sustained wind velocity is 46.2 meters per second. So this is the sustained wind velocity, which is, if you look up here, the sustained wind velocity is v. Okay, so this is our output here. So we have a number for the output. We're asked to find the air pressure. This is the thing we don't know. That's the P. So we're going to be solving for P here. So the way we do this is we want to take that equation and we want to replace the output with the given value. Okay, now when we do this, whoops, I have a value for that.